Hi everyone! Today I'm going to be going over memory addressing modes. In particular, I will be going over indirect memory addressing. We'll go over the formula, breaking it down, each part, and then we'll go into some examples of how we can apply it as we go through our assembly instructions, as we are trying to dereference registers, as well as moving data. To begin, we're asked to describe and define the pieces of the memory addressing modes formula. I just wanted to clarify that there are two different types of memory addressing modes. There's effective and there's indirect. Effective is when you just get the address itself. So the syntax would be A, where A is the address, and then an example would be 0x dead beef. However, in some other cases, such as in indirect, we have to get the address that is stored in a register. So we have a register, let's say we have some register here, let's say it's RAX, and within this register we have A, our address. This is what the syntax looks like for our formula. We have D on the outside. D is equal to our displacement. RB is our base register. RI is our index, and we have our scale. And the computation that you get as a result would be D plus RB plus RI times S. Our stack grows towards the lower memory address, and then let's say we have 0x10, 0x8. Okay, here's an example of what it might look like as we use our indirect memory addressing. Over here on the left, we have our registers. We know that RAX holds the memory address. Again, this is our address, 0x10. RDX has an unknown value, and then we have this instruction over here. On the right, you'll see our stack. We have our memory address over here, and then we have our values here. So when we look at this instruction, the first thing we should notice are the parentheses. This means that we're doing a sort of dereferencing move where you first need to go to the address and get value starting at the address. Once we see these parentheses over here, that should indicate to us that we are doing indirect memory addressing. So our first step is to identify D, RB, RI, and RS. D is this implicit value over here. RB, this area in front of the comma. RI is RAX, and then our S is 1. Our D is just 0. RI is 0. So all we have to do is do plus 0 plus RAX, which is 0x10, 0x10, times 1, which equals 0x10. So now we finally have our memory address. And then, so we've gotten our first step, which is 1, get the memory address, go to the address. And second, we need to get the value starting at this memory address. So then at this point, we're going to go to the stack, and then we'll look at our memory addresses. 0x10 is over here, and then we have to go into this value over here and get 0x1. So then we get the value 0x1, and our instruction is to move, and we need to move 0x1 into RDX. So this value would be 0x1. So that would be the final answer. Notice how it's not enough to just get the memory address and put it into RDX. What you need to do is get the memory address and get the value starting at that address. This is just a small example, indirect memory addressing. Thank you for watching, and I hope this video was helpful.